All right, so now onto another live stream for covering transformations of functions. So what I'm going to do here is just going to kind of work through some different examples. We're going to look at applying the transformations of a function in f of x kind of notation. We are going to look at transferring different types of our 12 basic functions, as well as giving like a rough sketch and then determining the domain and range. And then we'll kind of work through some multiple choice questions. And then for those of you that kind of want to go a little bit extra, I have some challenge problems that you can kind of work on that. Really just kind of, kind of take it a little bit to the next level, really kind of deepen your understanding of what we are really doing with those transformations. So just like my previous live streams that I've done before, if you're coming into the chat and you have some questions that you'd like me to maybe cover in your class that's not covering transformations of functions, I am going to kind of cover this directly or like all together, and then what I'll do is I'll kind of answer some questions as after I am done with working through this assignment. So I'm going to kind of go from the beginning to the end, and then after that I will be open to any kind of questions and helping you out. So hey J-Train, I'm glad you could join in. Looking forward to another stream. So I probably have slated here roughly around 30 to 40 minutes. So hopefully this won't take too long. As I mentioned, I'm just going to run through this, and then if you guys have any questions or anything else I can do in the meantime after I'm done, then let's get on to it. So without further ado, let's get started. So all right. So the first one is saying identify the following functions applied to f of x. So we have our function f of x, and then what we did is have some numbers added, subtracted, multiplying, and technically dividing. And what is that really going to be doing to our function? And the problem with this question, not really the problem, but usually the kind of issue we have here is we don't know what the function is. We don't know what the graph looks like, or what the function properties are. So when we're looking at fx, there's really kind of like some general rules that we have for our transformations. And let's kind of zoom in here. So our different types of transformations, we have a times f of b times x minus c plus d. Okay, so I need another parenthesis there. Okay, so that's kind of like your basic. So we could have multiply by a on the outside of the function. We could multiply by b on the inside of the function. We could basically add or subtract a c and inside the function, or adding, subtracting a d in the outside of the function. And basically these all have different characteristics of what they're going to do to our function. The main thing that I am going to kind of drive home with this is a and d are outside of the f of x. They're being applied outside. So I'm just going to write that, outside. Whereas b and c are being applied inside the function. Okay, and we'll take a look at that. That will come hopefully more apparent as we look at different types of functions. So the main thing is a is basically going to be a dilation, vertically stretching or compressing. If a is negative, it reflects about the x-axis. And yeah, that's about it. B is a horizontal compression or stretching, and if B is negative, you reflect about the y-axis. C is basically going to be our horizontal shift. The opposite of C is telling us that it's going to be in the opposite direction. So if it's like, +5, then you're going to shift 5 units to the left. And then D is going to be our vertical shift, basically moving the graph up or down. And it's plus D, meaning if it's +5, you go up. If it's -5, you're going to go down. So let's get into the first example. So we have a function f of x and then +2. So what we want to do is kind of relate, well, what is this 2? And so for all these equations, we're basically looking at like what letter does this correspond to? And since we're adding a 2 outside the function, this is like adding a d. So our 2 is basically just going to be a vertical shift up 2 units. So all I'm looking for you to do is just be able to describe this. So we could say, shift up 2 units. And I'll just write 2 and up there. So that's really the only transformation that's going on. But notice how this f of x is like closed and it's ending, then we're adding 2. That means the 2 is outside. Whereas here you can see the 2 is inside the parentheses. So this is really representing C because it's inside. And what we talked about in class was we looked at how the inside functions are really going in the opposite direction. So while it might make sense if since 2 is positive that goes up, 2 is negative goes down, that means 2 on the inside should be going left, but actually it's going to be a shift 2 units to the right. I'll just say right 2 units. Okay, and that really is best understood by looking at the graph. If you graphed any function with x minus 2 on the inside, you would see that it gets transformed 2 units to the right. In this next example, we have 2 transformations that's going on. We basically have a negative on the outside, and we're multiplying by 3 on the inside. So basically, this can be thought of as like a -1. So you're really multiplying by a -1. That means A is going to be a -1. Well, since A is 1, that's not going to be a horizontal stretch or compression, but that negative is going to tell us we are going to reflect the x-axis. Because again, that's vertical. A and D are outside. I should probably write that. So outside means vertical transformations. And inside is going to mean horizontal transformations. Okay, so we have to reflect the x-axis because that's vertical. Okay, and then when multiplying by 3, that is actually going to be a horizontal compression. And I'm just going to abbreviate that. Horizontal compression of factor of 3. All right. Now let's go ahead and look at this next example. So now in this one, we are adding a 1. So you can see that that is going to be a transformation inside the function, and then we're subtracting a 4 outside the function. So inside the function is horizontal, so that's going to be a horizontal shift. Remember, it's in the opposite direction, so that's going to be shift left 1. And then subtracting 4 on the outside is going to be a vertical shift, which is going to be down 4 units. So we could say shift down 4. All right. In this next one, you can see we're multiplying a 1/4 on the outside, so that's going to be a vertical stretch or compression. Since 1/4 is between 0 and 1, that's actually going to be compressing the graph. So for all values that you're multiplying that are larger than 1, those are going to be vertical stretches. But since this is between 0 and 1, it's going to be a vertical compression. So I'll do vertical compression, and that's going to be a factor of 1/4. Okay, and then just remember multiplying here on the outside was reflect the x-axis. Here you can see we're multiplying by a negative on the inside, so that's going to be reflect the y-axis. All right, and last, my absolute favorite. This one has f of 2x plus 6. So you can initially think of this as saying, oh, well, there is a horizontal stretch or compression, right? And notice here that since 3 is larger than 1, that's actually a horizontal compression, which is kind of like the opposite of what you would think for vertical ones. So this is going to be another horizontal compression, a factor of 2. But a lot of students will get confused and they'll think, oh, well, this is going to be this is going to be 6 units to the left. Well, again, we have to write this equation in this format, meaning we got to make sure we factor the b out. So if we have a b and we have a c, we were going to want to make sure we factor out that b. So before I actually get any farther, I'm actually going to rewrite this as f of 2. So if I factor out a 2 from 2x plus 6, I'm going to get x plus 3. Now you can see that there is, yes, indeed a horizontal compression of 2, but rather shifting 6 units to the left, I'm actually only shifting 3 units to the left. And when when you look at the graph, you can see if you were to graph any kind of function with 2x plus 6 inside of it, you would see that it's only shifting 3 units to the left. So we'll just write that as a horizontal compression of 2, and that's a shift left 2. No, not left 2. That's left 3. Okay, so that is what we do when we have something in function notation. And again, that's a little vague because we don't know the function and it can kind of get a little confusing. So I think the best way to really kind of understand these is give you some functions that you can graph. And I didn't provide the link for these, but I would just recommend taking these functions and going to Desmos, desmos.com, and graphing them for yourself. It's free. And what you can do is you can just verify that these are the correct transformations. Before you go ahead and graph them, though, it's important to make sure you know what the graph of the parent function looks like. So for each of these functions, I will graph the parent function because I think it's really important to graph the parent function and then graph the transformation so you can see how that graph was, shifted or moved. And the other thing that's important is I'm not going to write the transformations like where A, B, C, and D is for each of these functions, but you can see that they're all going to be the same. The only difference is the actual functions. Now you can see f of x here is that we be x squared. Here f of x is absolute value of x. So it just kind of really changes. But the a, b, c, and d do not change. So in this example here, my parent function is going to be, let's see. My parent function in this one would be f of x equals x squared. Okay, so now what you can see is there's a lot of things going on. We're multiplying by 2 on the outside, right? We're subtracting a 1 on the inside because they're inside these parentheses, and then we're subtracting a 2 on the outside. So kind of keeping that form of of those notes up there. Actually, let me just write that out. Why not? Let's just write that out in our notation here. So this would be a times b x minus c squared minus d. So in this case, there is no b, but we do have an a, a c, and a d. So actually, I'll write that. Why not? So our a is going to be, since a is larger than 1, that's going to be a vertical stretch, factor of 2. We have a c, which is negative 1. So, or c is really, positive 1, because you're x minus c. So it's really like x minus c. Right? So it's really 1, so you're shifting it 1 unit to the right. So we're going to say shift 1 right. Oh, let's just say right, shift right 1. And then we're going to shift down 2. Okay, so then it says sketch the graph and determine the domain and range of each function. Kind of adding these up. Now, what's nice about having this parent graph here is I'm actually going to I'll draw the parent graph for each one of these so you guys can kind of see. And if you don't know the parent graphs, I would highly recommend that you know what these parent graphs are so you can see the transformation. So the x squared is just going to give you your random, not your random, but your consistent little parabola for you. And then if I'm going to apply these transformations, let's just kind of go through it. So a vertical stretch of 2, I'm not really concerned of that, but you are just stretching the graph, factor of 2. But this graph is being shifted right 1 and down 2. And the easiest point to really, rather than like worrying about shifting all the points, the easiest one for a quadratic is just 0, 0. So just shift that point 0, 0, 2 units to the right. I'll do that in red. So 2 units to the right and then 1 unit down. And then I'll try to stretch it a little bit too. So it's a little bit skinnier. Okay, and then it says determine the domain and range. Well, since this function is continuous, all right, and you can see the graph is continually expanding, the domain is going to be from negative infinity to infinity. And the range, again, the function is continuous, but you can see that it is bounded below. It only goes below negative 1, but it does contain negative 1. So it's going to be negative 1 to infinity. Okay? All right, so now on to the absolute value function. So you can see here we have this absolute value. So the parent graph is that V graph, if you remember. If I was going to write this in terms of transformations, this would be A, absolute value of B, x minus c plus d. All right. Now, in this case, we have an a, which is negative. So multiplying a negative on the outside, that's reflecting the x-axis. I do not have a c. I'm not adding or subtracting inside of the function, but you can see that I have a multiplying by 3 inside. So that is going to be a horizontal compression, factor of 3. And then you see I'm adding a 2 on the outside, which will be my vertical shift up. So I can say a shift up 2 units. Okay, so let's go ahead and draw the parent graph. So the parent graph is that lovely V graph. Okay, now this is getting vertically compressed. So vertically compression is very similar to vertical stretching. It's going to have like the same effect. It's not always the same, but it's going to have that same effect. And again, just like a quadratic, the easiest thing to transform for the V-shaped graph is like the vertex, like the lowest point. So if I wanted to, so all I got to do is shift this up 2, and it's just going to be, oh, and it's reflected about the x-axis, right? So let's reflect it and then go up 2. Okay, and then it got reflected, so it's going to now be facing down. Okay, so now you can see here the domain basically got flipped around. Rather than going from 0 to infinity, you can see now the domain is going from negative infinity all the way up to positive 2, but it includes 2. I'm sorry, I was thinking of the range. Well, so yeah, sorry. The domain is the set of all x values, right? So the domain is going to be how far the graph is expanding. It's a continuous function, so the domain is going to be negative infinity to infinity, and the range is going to be, sorry, from negative infinity to positive 2. Okay. So now into the next one here, we're going to have the absolute value. So the absolute, not the absolute value. I got to like slow down. It's not the absolute value. We're talking about the reciprocal function. So j of x equals 1 over x, all right? And so what am I thinking? Oh, the transformations. So j of x can be a times 1 over b times x minus h plus d. Okay, and sometimes we write the a just up top in the numerator, but I wanted you guys to see it still being multiplied, but a lot of times we'll just write it up and top. So in this case, why am I using h? I don't want to use h. I want to use c. I want to be consistent, right? You don't want me writing some random stuff. C. Okay, so in this case, you can see we're adding a 2, but that 2 is in the denominator, so that's going to be my c. I'm adding a 3, which is going to be my d, which is going to be my vertical. So c, horizontal, d is going to be my vertical. So let's say we're going to do a shift left 2, and we have a shift up 3. Okay, so now let's make sure we know what the parent function is for the reciprocal function. That's going to look something like this. Okay, and it's important to also understand that the reciprocal function has asymptotes. It has a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. So when we're looking at this, now if we want to apply the transformations, what I usually just transform is the intersection of the two asymptotes. So the intersection of these two asymptotes is going to be shifted left 2 and then up 3. So what I'm going to do is I'm just going to like redraw these asymptotes because the vertical asymptote got shifted left 2 and the horizontal asymptote got shifted up 3. And then I'm just going to kind of like re-sketch my graph. Not going to be perfect or pretty. But now you can see that now the domain and range is a little bit different because remember this is not a continuous function, right? So the domain is only going to be for all values except for where the asymptotes occur. Well, you can see the vertical asymptote in this case occurs at -2. So it's going to be all real values except for -2. In interval notation, we'd write that as negative infinity to -2 union -2 to infinity. And the range is going to be the set of all y values except for y equals 3. So for interval notation, I would write that from negative infinity to 3 union 3 to infinity. Okay. All right. Welcome, guys. Everybody join in. Just a quick little break here. If you do have some questions, what I'm going to do is I'm just going to work on finishing the rest of this kind of worksheet for homework. And then if you guys have any questions, I'll spend about 10 minutes afterwards and help you guys out. So I really appreciate you guys coming in. And let me know if you guys have any questions as I kind of wrap this up. I only got these questions, and then I got some multiple choice, and then we'll be all done. All right, so next example, you can see this is the square root function. And for the square root function, the parent function is just the square root of x. Okay? And the transformations then, if you guys kind of notice like the pattern I have here, it's kind of the same thing over and over again. It doesn't matter what the function is. B times x minus c. I'll close that radical. plus d. And you guys see I can do this for any function. It doesn't matter what the function is. I just plug in the a, b, and c so that I can transform it. Now the problem with this one, this doesn't look like anything there. So let's rewrite it in that format. So let's rewrite this k of x as, let's first rearrange the x's, and that's a positive one. Now I have, in this case, you can see I have a b and I have a c, but I don't have it factored out. So what I'm going to need to do is factor out that negative 1. So in doing that, I have a negative 1, and that turns into an x minus 1. Okay? So when multiplying by negative 1 inside of the function, that is going to be a reflection about my y-axis. So I'll just say reflect the y-axis. And since I'm subtracting a 1 inside of the function, that's going to be a shift right 1 unit. Right 1. Okay. Now let's go ahead and look at what the parent function of that looks like, of the square root function. So that's going to be something like this, and then just kind of continues going in that direction. Okay, so it's continuous, but it's not continuous for all intervals, only for positive numbers. So this function now is being reflective about the y-axis. So instead of force showing going to the right, it's now going to be going to the left, and then it's being shifted 1 unit to the right. So now what you can see is my domain has been kind of flipped around. So now my domain is from negative infinity to positive 1. 1 is included, so we're going to keep it there. And I use those as parentheses, right? Yeah, because again, you want to use parentheses for these numbers because they're at asymptotes, they're not defined. Whereas over here, 1 is defined, so it works. And you can see my range here is the lowest value is 0, but the highest value is going to be infinity. Okay. All right, sine function. Now we don't talk too much about sine function because we spend a whole chapter on it, but I think it's important just to kind of, get you prepared for coming up with this. So the parent function of the sine function is basically just sine of x. All right, and again, going through the transformations is going to be a times sine of bx minus, so let's put an extra parentheses, minus c. Minus c and then plus d. Okay, and you can see in this case, all we're doing is adding a 1. So all I'm doing with this graph is shifting up 1 unit. So to understand the domain, though, and the range, we kind of need to understand what the graph looks like. So sine of x continues in this kind of pattern. It's a nice little wave graph, all right? That's a really bad sine graph, but hopefully you kind of get the idea. If I am going to be shifting this graph up, I'm basically just going to graph the same graph here. And just kind of follow like that. And this is really harder than I thought it was going to be. Okay, really bad. But anyways, what I want you to at least see is, if we're looking at the domain is undefined. I mean, not undefined, but it's continuous for all intervals. So the domain is kind of easy for this one. Domain, negative infinity to infinity. Now the original parent graph goes up to 1 and goes down to negative 1. So that was the original graph, up to 1 and down to negative 1. So if I shift it up 1, now the lowest point my graph is going is 0, and the highest point my graph is going to go is 2. So this graph is bounded. Obviously, it has a max and a min. So the range is going to be from negative 1 to 1. All right. Last but not least here is we have our logarithmic graph. And logarithms exponential is one of those functions I think students kind of forget the easiest coming into my class. So let's just kind of go through again. There's nothing wrong with logarithms. So that's L of x equals ln of x. All right. And the transformations, again, just the same process, guys. I mean, a times ln of bx minus c plus d. Okay? And here you can see we're multiplying my ln by a negative, right? Negative 1, so therefore that's going to be reflect the x-axis. And then we're adding a 1 inside the function, so that's going to be a shift left 1. Okay? Now the parent function of ln of x looks like this. kind of like a square root one and a reciprocal one. And there is a vertical asymptote at y equals 0. Okay, and there it intercepts at 1, 0. So if all I need to do is reflect this about the x-axis, that means this graph is now being reflected and everything's going to be shifted over. So that means the asymptote is going to be shifted over 1. And the new x-intercept is going to be at 0, 0. And I'll try to do my best here. Boom, just like that. Okay, so now I basically just need to identify the domain and range of this function. Well, the domain only goes as far left as -1. So, and since it's at an asymptote, that's going to be not included, and that's going to continue going to the right to infinity. And my range, you can see this graph kind of continues indefinitely going up and can definitely going down. So that's, why am I using brackets? I don't know. So that's going to be negative infinity to infinity. Okay, so that's basically what we're doing is, the main idea that we come across when we're given functions is, understanding, guys, the parent function, knowing what the graph of the parent function looks like, identifying the A, B, and C based on the different function that you have, and then being able to identify not only transformations, but being able to graph that. And the only other thing I want to mention to you guys is when you have, kind of going back to what we originally talked about, when you have outside vertical transformations like A and D, those are going to affect your range. If you do not have any transformations A and D, then your range will be unchanged from the parent graph. The inside transformations are going to be affecting your graph horizontally, so they're going to affect the domain. And if you have a function where there are no inside transformations, then your domain is going to remain the same as it was with the parent graph. And that kind of speaks to my next example here of my first multiple choice question. And the multiple choice question, you have a domain of -5, 8. Well, what is the domain of f of x plus 2 minus 1? So we got to think, what is happening to the graph? The graph is being shifted left 2 units, right? And it's being shifted down 1. So think about this. The first coordinate x represents the domain, right? That's like your horizontal point. So if I'm going shifting left 2 units from -5, I'm now going to be at -7. And your y coordinate really represents like the y portion. Oh, I'm sorry. If your domain is that's the domain, right? I got to be careful. So your domain fx is -5 to 8. So if you shift it left 2 units, that means you're going to have to subtract 2 from -5 and -2 and 2 from 8, which would be 6. Okay. So therefore, my first answer would be A. We aren't concerned with the -1 because the -1 is shifting the graph up or down. That's not affecting the domain, right? The domain is what it is, from left to right. Question number 2. Suppose x equals 6 is the vertical asymptote. Okay, which one of the following must be the vertical asymptote of 2 and 3? So this kind of plays into the stretching and compressing. Notice that when we're adding and subtracting, that's the only thing that moves the graphs. When we're multiplying or dividing, that is what is just stretching and compressing the graph, right? So multiplying by 2 is a vertical stretch. That doesn't affect the domain and range. Multiplying by 3 inside the function is a horizontal compression. That's not affecting the domain and range. So the only thing that moves the graph left or right is your C and your D, and we don't have any of that here. So, and again, reflections wouldn't affect the asymptotes. In this case. So we don't have to. The asymptote remains unchanged. So the answer is E. Next one, write the expression for the function whose graph y equals x2 is shifted down 4 units and left 5. Okay, so I know left 5, right, is going to be inside the function. So let's write this transformation. Y equals A times B x minus C cubed plus D. Okay, so left 5, remember, is going to be a positive 5. So that means we're going to be adding 5 inside the function. And then we're going to be shifting down 4 units. So that's going to be minus 4. There is no B and there is no A. So I don't need to worry about including A or B. Those can just be like 1. So my equation would y equals x plus 5 cubed minus 4. And let's see, where is that? Right there, B. All right. And then last but not least, guys, you can get a graph y equals negative g to the 2x by transforming the graph of y equals gx in the following way. So you can shrink horizontally, reflect across the x-axis. All right, so first of all, let's look at the negative here. The negative is telling us it's reflection about the x-axis. So therefore, I don't need to worry about the y-axis or y-axis. All right. Now you got to think, is it vertical would be meaning outside. Well, you're multiplying by 2 inside, so it's not going to be anything vertical. And shrink, I was using compression, but shrink and compression would be the same thing. So shrink horizontally and reflect about the x-axis. There you go. Okay. And the only thing I like to do is give you guys, some challenge problems. You guys can think of working on these. I'll provide the answers to my students, but, for those of you that are kind of joining the video, if you want to kind of work on these and, kind of see how I do, I think it's a good kind of challenge problem to wrap up the lesson. So, there you go, ladies and gentlemen. I am finally done. I do have some time to answer some questions. Not much, but I do have 10 minutes. So I'll just kind of get into the chat and just kind of see. Hold up. I do appreciate for all you guys that have joined in. Whoa, Jane Hader, $40, man. Jeez, what? I appreciate all your work. I don't know what you're giving me $40 though for on the super chat. So Kyla said, hey, Kyla Jean, happy to have you here. I won't tell any you're a teacher, but I'm happy to be able to help you out, answer any questions I can. Min Tran says, I need your pre-calc videos when I start school. Well, you are in luck. I am only teaching pre-calc this year, which is good and bad. I do miss calculus, and I do kind of miss the variety of teaching like 2 classes. But the good thing is, since I'm only teaching pre-calculus, I really get to kind of dedicate for you guys as well as my students, making sure that I can provide, live streams every week. Because even like last year, I tried to do live streams, and it was just too hectic. I had too many things to do. Preparing for, AP Calculus took a lot of my time. And so I just wasn't able to do it. But this year, I'm pretty excited because I get to, really kind of work on all of this material that I'm creating for my class. And that, and also I have a little bit of extra time to do, live streams. I want to do the live streams for my homework, kind of like what I'm doing, so that you guys can, take advantage of it, and well as my students can help you guys out. QB says, you're the best. Thanks so much, man. Appreciate it. Sahil, happy to help. And Bork and Josh, awesome to see you guys. So, well, if you guys have any questions, I will be more than happy to answer them. Otherwise, I guess I'm just going to doodle and wait for you guys to kind of see. But I guess maybe I can let you guys know what's going to be coming up, at least in my class. So as far as scheduling goes, live streams, we probably might have a live stream next week. We're going to be testing, and then I'm going to be heading out of town. So we probably won't have any live streams next week, but at least as far as coming up topics. So let's say coming soon. All right, so coming soon, we are going to talk about operations of functions. Let's get that in there. Never mind. Not operations of functions. Yeah, we're going to talk about operations of functions, but actually the next thing that we're going to do, the next assignment that I'm going to go over is piecewise functions. Why does this look so bad? Piecewise functions. Okay, and then we'll do operations of functions. And then we'll do inverse of functions. And then we will take our test and we'll get into polynomials. So if in your class you are and this is something that you are going to be covering in your class, make sure that you just are aware of my live streams, because I will have new videos coming up on all 3 of these, topics, as well as some live streams for the homework. So therefore you guys can, kind of follow along with my class. And then we'll get into polynomials, trig, and then like kind of the traditional kind of course. So CX, I don't know what you're on. After you're done, can you go over finding limits of functions algebraically? Yes, Matt Evan, I'll be happy to do a limits problem I am all done. So I'm really just kind of waiting to see if anybody has any questions. So if you have a limits problem, if you just want to kind of let me know, don't worry about writing the limit notation, but if you want to maybe give me the equation and just tell me to find the limits, from where it's at, then I can do that. I can do a little overview for you. Obviously, limits, can be something that we could take a lot of time on. So if there's anything specific that you want me to really address, I can go and do that for you. So just let me know. I'll try to hold off for you guys and kind of see, my topics. But yeah, this is the stuff we're going to come into. Oh, and I want to let you guys know too that I don't have this in store yet, but I do have some of my constant cheat sheets as well as quizzes that I will be making available online, that if you guys want to go ahead and work on those, like get some extra practice solutions, I'll have that be coming up. Unfortunately, though, however, if you do want access to my, these sheets that I have, all of my homework and all the stuff that I'm creating, that's only available. It is available, but it is only available as far as a sponsorship or as far as on my Patreon account. So those are just kind of things I am kind of being a little exclusive on, just because I do spend a lot of time, creating these and working through them. Everything I create, I work through them once, creating them. And then I have to work through them again to, check out mistakes. And then guess what? I still make mistakes, even as I'm making the videos. But so those are kind of things exclusive. If you do want to kind of check out, how these, if they help you out, check it out. See if you like that kind of mode. But I do have all of my notes, guided notes. I do have my guided notes, investigation, all these homework sheets. So all the blank and answer copies are available both on the YouTube sponsorship as well as the Patreon page. So if that's something that interests you, go and check it out. I do have some other things on there that I offer, but one thing I will be doing, at least on just the YouTube channel, not exclusive, is making sure that giving you guys some more cheat sheets as well as some quizzes. But again, that's a little bit dependent on my time. As far as what I'm able to, how much I can create and get out to you guys. But I will plan on having that stuff coming out soon, hopefully. All right, so we'll kind of see. This is my first year in 2 years I don't have a new child that's coming into the world. So last year I had my second child. The year before that had my first child. So trying to do all this YouTube stuff and teach a full-time job and do real estate was kind of crazy. So it wasn't something I would wish on too many people, but I got through it, and now I'm just trying to take a little bit of that extra time and that I have in the evenings after 9 o'clock, the kids are in bed, to kind of work on some stuff and get everything organized and ready for you guys. So let's see. Yeah, doing limits. I'll be happy to do some limits. You guys just kind of need to let me know. If you guys have anything, I know in the chat, I'm probably going to end this, rather quickly, see what I can do. But if you guys have the, I'm trying to think if anybody knows of anything that might be good for you guys where to submit questions. I was thinking about doing something, on Facebook. You can at least submit a picture of the question, whatever else. I'm not sure if there's another service that you would do that would work. So I'm kind of open to suggestions. For instance, I know a lot of people rather than typing their equation, it's easier for them to, take a picture and send it. Well, obviously the chat feature of YouTube is not really conducive to that. And I'd like to be able to kind of get some questions that I can answer some people to help you guys out when you take the time to send them to me, see what I can do for you. And also it helps to look at the question before I just randomly get it going live and be like, oh, I can do this, or I just don't know, I'm having a brain fart right now. So if anybody has any suggestions on ways to do that might be feasible, I am more than happy to look into what you would suggest, because I'm not sure exactly. I'm looking into Facebook might be a possibility, using my Facebook group or messages to do that, but I'm not sure. All right, Jordan finished that, 84. Awesome, Jordan. Good job, man. And how to add integers and fractions. All right, and I can go ahead and make that. Make a subreddit or a Discord. Okay, subreddit, that's not too bad. Homework calculator. All right, Jordan, I'll think about that. Doing a subreddit, and then you guys can kind of, I'm not very active on the Reddit, so I'll have to go and kind of check out that feature, and we'll kind of see. But I like that idea. Something new, something I'm not used to. So adding integers, I'll go ahead and do this one for you. NYC Allen, and then I will jump off the stream because now I gotta kind of run off. It's been about 40 minutes so far. So let's just do a couple examples here. Why don't we adding integers? So let's do like 2 plus, let's just do plus 1/2. Let's do -3 minus, let's do 4/5. You just said adding, but I'm going to add and subtract. And let's just do 2 1/8 plus 1. There you go. Let's see how this works. Okay, so the main important thing with adding fractions, or adding fractions with integers, I think the easiest thing to understand is just convert your integer to a fraction. Any number can be rewritten as a fraction. If it's an integer, just put it over 1. Okay, and the main important idea with fractions is if you have fractions, to add them, you have to have common denominators. As long as the denominator is the same, then you just combine, add or subtract, the numerator and keep the denominator as is. But you have to have common denominators, all right? And so the main important thing to understand with, doing this is right now I have 2 over 1 plus 1/2. Well, if I want to get this to be common denominators, like think about this. If I look at, 1/2 and I multiply 1/2 by 2 over 2, I now have 2/4. Well, 1/2 is equal to 2/4. Are they exactly the same? No. But are their values exactly the same? Yes. So as long as you multiply the same number on the top and the bottom, you produce an equivalent fraction. So you're not actually changing the value. So I need this to be a denominator 2. That means I need to multiply the denominator by 2, and I need to multiply over here by 2. So then what I'll have is 4 over 2 plus 1 over 2. Well, now I have common denominators, so I just simply add the numerators, which is 5 over 2. Okay. Now I like leaving everything as improper fractions. If you're asking this question, you might have to work into mixed numbers. So to divide in mixed numbers, just take 2, divide it into 5 2 times with a remainder of 1 over 2. All right. In this example, we have 3. We can change the -3 over to a 1, and then again to get common denominators, just multiply by 3 over 3, because again I want this denominator to be 3, right? So when I multiply on the top and the bottom, I now produce a -9 over 3 minus a 4 over 5. Now you might say, well, should the negative be up top or on the bottom? Like, where does the negative go? And again, it doesn't really matter. Like, -4 divided by 2 is -2. 4 divided by -2 is -2, right? So it doesn't matter if it's in the numerator or denominator. Obviously, we're applying what am I doing? I need this to be 5. Why did I multiply by 3? Sorry about that. I think I just got talking and didn't listen to what I was saying. So let's get that. That's wrong. We need this. This is 1. We need this to be a 5. So I'm going to multiply by 5 over 5. So therefore now I have -15 over 5 minus 4 over 5. Okay, and you could rewrite this subtraction as plus a negative. That helps you out. Sometimes that's easier with negative numbers because now they have common denominator. You can see that this is going to be a -19 over 5. And again, I hate mixed numbers, but let's just write this in mixed number. 5 goes into 19 3 times with a remainder of 4 over 5. Okay, because 3 times 5 is 15 plus 4 is 19, and I forgot that's a negative, right? Make sure you keep the negative. All right, so does it matter if we add a fraction to a number or a number to a fraction? No, right? It doesn't matter the order. In this case, though, we have a irrational. Oh, why didn't I pick a rational? Yeah, whatever, doesn't matter. This will be improper. So if we have a fraction here, there's a couple different ways to do this. This is really a whole number. You could simply just add this in as 3 1/8. Really that easy. That's the whole number. That's the fraction. Okay. Or, obviously if you want to just if you have to convert this to an improper fraction, remember do 8 times 2, which is 16, plus 1, which would be 17. So that's going to be 17 over 8 plus 1. Now the only reason why I want to show this is, again, how would you add 17 over 8 over 1? Well, again, write this as a fraction and get common denominators. So therefore I have 17 over 8 plus 8 over 8, which equals 25 over 8. And if I wanted to convert this to a mixed number, 8 goes into 25 3 times with the remainder of 1. So therefore that's 3 1/8. And there you go. All right. Geez, man, now you guys, see why you guys are coming there. Okay, now what is 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32? Okay. Well, Kale, hey, man, I'm sorry. Happy to help you pass your pre-calc exam, man. Good work. I'm happy to be there for you, but, you know, you're the one that put in the effort, so I do got to commend you for that. So as far as adding fractions, I'm not going to do this, but I'm going to tell you what to do. So if you're going to add all these up, you got to get common denominators, just like the problem I showed you. You have to get common denominators. So you got to look at these and say, what is the common denominator of all of these fractions? And you look at this, the only number that all of these denominators all divide into, the LCD, is 32. Right? So we can write this as 1 over 1. 1 divides into 32. 2 divides into 32. 4 divides into 32. 8 divides into 32. 16 divides into 32. 36 divides into 32. So then all you need to do is get that. So you got to say, so you got to get all these numbers to be 32. Well, to get this to be 32, I got to multiply by 32 over 32. To get 2 to be 32, I got to multiply by 16 over 16. Right? To get 4 to be 32, you got to multiply by 8 over 8. 4 over 4. 2 over 2. Right? And then once you get to that point, add all the numerators and then keep the denominator as 32, and that will get your answer. So, all right, guys. Well, I'm sorry. Where is he? Sorry, Mahaven, I'm going to have to let you go, but I'll look into that subreddit. I'll maybe next year I'll let you guys know. Again, just a reminder, guys, I'll probably take a week off from live streaming because we're not going to have much homework going on, although we might. That's actually a good idea. Maybe I will do a live stream before I leave. Good idea. Let's plan on that next Wednesday. We'll do another live stream. We'll talk about piecewise functions. So next Wednesday we'll do piecewise functions live stream, and that'll be helpful because that was perfect. All right, so we'll do that next week. So I appreciate it. If you guys have questions, let me know. And otherwise, I'll put the subreddit. I'll look into that tonight. And what I'll do is I'll put that in the community tab. So if any of you guys are on my channel and you actually see the community tab or read it, I'll go and add that in there, and therefore you guys can kind of check in and send some questions. So therefore I can devote some time to reading that. But besides that, guys, I think we are all set. So cheers. Have a good rest of your day. Come on. Seriously? I said finish.